So now when you talk about what's the difference between explicit and implicit function. Now, so far, whatever we did, you could see that y was the subject of the formula, and you had the function right in the right was purely in terms of x. So when you say y equals to fx, this is your explicit function. Now, implicit function generally it is like f of x y is something like as a constant or something like that. So when you talk about implicit function, generally you will see a mixture of x and y together. Like for example, if I have, let's say x squared, y equals to x squared plus 4x plus 3, this was implicit function, explicit function. But if I have something like this, y cubed minus 3x squared y plus 4x equals to 7 or equals to 0, whatever it is, then it is referred as an implicit function. You can see x and y are together. Now here the strategy that you differentiate is not much different, but it is important that you take care of certain points that I'm telling you. Number one is that, let's say when you differentiate an expression, let's say you're differentiating with respect to x still, but you're differentiating function y. You're differentiating function y raised to n with respect to x, which is we didn't do so far. Like here, in this case, we were finding the rate of change, like dy by dx with respect to x. So it was okay, 2x plus 4. But if you have a function which is in terms of y and you're differentiating with respect to x, little bit of challenge that we get is, first thing is that if I have, let's say, a function f equals to something, let's say y equals to f of x we have, okay, so y equals to f of x we have, this is simple to differentiate. But when you have a function in terms of y to the power n or something like that, just remember this step. That what we do is we first differentiate this function. Once again, it's like chain rule. Okay, consider this y, or let's say as a different function, and x to the power n is a parent function. Okay, so first differentiate the parent function. So if you differentiate this parent function, it will be n y to the power n minus 1, and then differentiate child function. So child function derivative will be, if I differentiate y with respect to x, it will be simply dy by dx. So when you differentiate y to the power n, just remember that the derivative of y to the power n is n y to the power n minus 1 times dy by dx. This is a straightaway formula to be remembered, and it's worth remembering this. If you're differentiating x to the power n with respect to x, no worries, it'll be nx to the power n minus 1. So this is something which we can remember that will help us. Now let's say, for example, if I'm differentiating y raised to 4. So here first I'll differentiate the parent function, will be 4y cubed times dy by dx. So this is the derivative of, the derivative expression for y to the power 4. Now, how do we use these to differentiate that implicit function? That is going to be interesting. So let's take this one example, which is a little easier one, and then after that we'll go to the challenging ones. So first thing is, let's say my function, let's say circle equation. One of the equation that is frequently assessed is circle. So x squared plus y squared equals to radius squared is the expression. And let's say what I'm asking is, you have to find out the slope formula for circle at any given point. And how do we find that out? So in this case, when you're finding out the slope formula, let's say x squared plus y squared equals to radius squared, you will have, if you differentiate both the side with respect to x, so you differentiate both the side with respect to x, you need to write this step. After this, what we have is the derivative of x squared is very easy, which is 2x, done, because you're differentiating with respect to x. Now y squared, you have to apply chain rule. So which will be 2y to the power 1 times the child function, which will be dy by dx, equals to derivative of r squared. R squared is a constant, which doesn't change. So derivative of that will be 0. So now here, when I differentiate, when I find out the expression for derivative, I get like this. So dy by dx will be negative 2x over 2y, which is negative x over y. So this is the formula for the slope at any given point on the circle. Now let's say 1, 2 lies on the circle. Now, if at that point, if I want to find out the slope of this tangent, that slope is going to be -1/2. So this is how you use implicit function. Now it'll be interesting to take one example where you have to apply product rule in the function itself. So let's say I have x cubed plus 3x squared y, let's say plus y to the power 5 equals to 8. And now I want to do the derivative of this function. So when you want to do the derivative of this implicit function, now what we do is derivative of this function will be apply first, write down this step. So here, now derivative of x cubed that you see is straight away 3x squared. Now the hurdle comes here when you have to apply product rule on x squared y because they are two different functions. So first step, let's do the derivative of 3x squared. So let's keep 3 as it is. X squared derivative will be 2x. So it'll be 6xy as it is, and plus 3x squared as it is. Now, what's the derivative of y? Like y to the power 1, derivative is nothing but dy by dx. Because if I do parent function, it will be 1 y raised to 0 times dy by dx. So in case if you're differentiating y with respect to x, we all know that's dy by dx. So don't need to do everything what I did here. So into dy by dx. Now plus y to the power 5 will be 5 y to the power 4, first parent function, times the child function, equals to 0. Because derivative of 8 will be 0. Now what you're going to do next is, you collect the dy by dx terms together and non-dy by dx terms other side. So in this case, what we get is dy by dx, if I take common, guys, we get 3x squared plus 5y to the power 4 equals to -3x squared, -6xy. So dy by dx will be equals to -3x squared, -6xy over 3x squared plus 5y to the power 4. Now, as you can see here, since it's an implicit function here, every time you're getting x and y together, like, sometimes the derivative will be in terms of x, sometimes it'll be in terms of y, sometimes it'll be in terms of both. So you shouldn't be surprised if you get something like that. So let's take this example where you have to differentiate, find out an expression for dy by dx for this particular curve. So sine of x squared y squared equals to 4x squared y. Now, this is an example where you will see that there is chain rule, product rule, and you have to carefully, that's why you have to apply your skills. Now here you can see sine of some function. So it's like first differentiate the parent function, which is cos of x squared y squared. So first step, you don't touch the child function. Into, now comes to the derivative of x squared y squared, which is the child. Now, so x squared y squared derivative will be x squared times the derivative of y squared, which is 2y, so times dy by dx, plus y squared times, as it is, times 2x, equals to, now here also product rule, so it'll be 4x squared as it is, times derivative of y will be dy by dx, plus y as it is, times derivative of 4x squared, which is 8x. So once again reminding, if you have y to the power n, its derivative will be ny to the power n minus 1 times dy by dx. So that's the formula I'm using when I'm differentiating y raised to n with respect to x. So if you open out the bracket, what you get is 2x squared y times cos of x squared y squared dy by dx plus 2xy squared times cos of x squared y squared equals to 4x squared dy by dx plus 8xy. Now after this, what will be the next step is to collect the dy by dx terms together. So when you collect the dy by dx terms together, what we get is dy by dx will be taken common, and here you have 2x squared y cos of x squared y squared minus 4x squared equals to 8xy minus 2xy squared cos of x squared y squared. And so you divide everything out here. So that's what will be your derivative. So if I divide this here, it'll be 2x squared y cos x squared y squared minus 4x squared. So that's going to be the derivative of this particular expression.